So this is a rational equation word problem. It's one that I classify as a mixing problem. It's actually found on page 572 of your textbook. So if you do want to open that up, follow along, or just refer back to it as you go through your homework problems, it can be found there. In this particular problem, we're told that Mia adds 70% acid solution to 12 milliliters of a solution that is 15% acidic. We want to know how much of that 70% acid solution should be added to create a solution that is 60% acid. So before we even get into any of the math involved with this, we got to make sure that we understand the situation that's going on. And to do that, I sort of like to envision that we have 2 or 3 buckets. So in our first bucket, we have the 70% acid solution. So this is our solution that is highly acidic. So I'm going to illustrate that with sort of a darker blue right here. Okay. And what we're going to do is we're going to add that to another bucket that has 12 milliliters of this 15% acid solution. So this second solution, we'll put a little bit lighter. It's not as acidic. Okay, so it's going to look something like that. What's going to happen is we're going to take this first bucket and we're going to add some of that liquid or some of that solution into our second bucket. The end result will be hopefully 60% acid solution. So somewhere sort of in between the 70 and 15%. Okay, so the key is we have to figure out how much of this we're going to add to this 12 milliliters in order for us to get to a 60% solution. So now that we have or should have an understanding of the situation that we're presented with, just do a quick review on percent. So we should know that any percent, so if we want a percent of the acid solution, excuse my handwriting, what that's going to end up being is it's going to be your total amount of acid divided by your total solution. So for this particular problem, we can kind of think of it as in that beaker that we have some acid in it and some water or other substances in it. And the percent of your acid would be the amount, the total amount, and in this case milliliters we have, divided by the total amount of liquid. Okay, so in order for us to find 60% of a solution, we're going to have to figure out the total amount of acid over the total solution. So now if we come back to our problem, we know that we want to take a certain amount of this 70% and add it to this 15%, which would give us then 60% of our final solution. Now we don't know how much of this first amount of acid solution we need to put in, so we're going to call it X, and this X milliliters. What we do know is that this 15% acid is 12 milliliters. So in our final solution, the amount of X milliliters we add to the 12, we'd be given 12 plus X as our total amount of solution. So if we think back to the equation from the last slide, that our percent is going to end up being the amount of acid over the total solution. Our 60% should be the amount of acid, which we haven't addressed yet, but our total amount of solution is 12 plus x. There's 12 plus x milliliters in our final solution. Now, although we do want 60% of that final solution to be acid, we should know at this point that we can't really do any algebraic math with percents. So we're going to take that 60% and we're going to make that its own rational expression. And we should know that 60% is just 60 over 100. Okay. So as you can see, we start to have our own rational equations start to develop. We have 60 over 100 equals the total amount of acid, which we're going to find out next, over 12 plus x. And that's the total amount of solution that we have here in our final bucket. Now to address the amount of acid that we have in our final solution here, we need to figure out first how much acid was in the first two barrels or buckets. So we'll start with the one that we know for sure, which is this 12 milliliter solution that has 15% acid. If 15% of the 12 milliliters was acid, we can figure out how much acid was in it by simply doing our 12 milliliters times 15%, which is 0.15. And 12 times 0.15 will give us 1.8. So 1.8 milliliters of that particular solution was acid. So back to our equation over here, we know that we have at least 1.8 milliliters from that second bucket. So we have 1.8 over here. And then we're going to add the amount of acid that we have from our 70% solution. Now we don't know how much we added here. So we're going to do x, but we do know that it was 70%. So 0.7. So however much we put in to that in milliliters into that solution, that second solution, we know that 70% of it was acid. So it would be 0.7x. So 1.8 milliliters from our middle solution plus 0.7x milliliters of our second solution would give us the total amount of acid in our final solution. So now we finally have our rational equation that we're going to solve on our next slide. So when we're solving this, we can get common denominators, cross multiply, however way your brain works. I guess I'll cross multiply. So I'm going to have 60 times 12 plus x equals 100 times 1.8 plus 0.7x. So at this point we'd want to use the distributive property. So 60 times 12 would be 720 plus 60x. Over on the right side, if I distribute the 100, we'd get 180 plus 70x. And now it's a simple linear equation. We'll move our x's to one side, our constants to the other. So I'm going to subtract 60x to both sides, giving me 10x. And I'll subtract 180 to both sides, giving me 540. So what we end up finding out is x, which we said was the amount that we have to add from our first solution to the second, is 54. So we'd have to add 54 milliliters of that 70% solution. Before you move on, just make sure that that makes sense in your head. So if we think back to our problem, we started with a 70% solution. We were adding it to a 15% solution, and we wanted to get a 60% solution. So it should make sense that we want to add a lot more of this so we can get it closer to a 60% if we're starting with a 15%. So 54 milliliters kind of passes the common sense check, and then you can go back into your work and sort of double check and make sure everything fits